start the discussion of the mock. This is a mock paper 4 set 3. You can use your mic, chat, or screen annotation to answer the questions from this paper. So the first one, figure 1.1 shows a helicopter which is stationary at a height of 1500 meters above the ground. State two conditions for the helicopter to remain in equilibrium. What are the two conditions of equilibrium?
No resultant moment and no resultant force.
So no resultant
No
moment,
resultant, no resultant turning effect.
no resultant turning effect, no resultant moment, no resultant force. There will be forces acting, but the resultant of the forces will be equals to zero. The next part, the mass of helicopter is 3,200 kg. Calculate the change in the gravitational potential energy as it rises from the ground to 1500 meter height. So the change in the height is 1500 meters and the mass of the helicopter is 3,200. We need the gravitational potential energy, which is mgh. The mass should be in kilogram because the SI unit of the mass is kg. So if they give in gram, always try to convert into kilogram. So it will be 3,200 times the gravity. What we will take? We will take as 9.8. Okay. And that will be mentioned in the beginning of the paper when you read the first, the front page of this exam paper. You will find that they say that take acceleration due to gravity as 9.8. And then 1500, so we multiply, we'll get the answer in joules. The next is figure 1.2 shows a vertical speed time graph for a parachutist who jumps from a stationary hot air balloon. The parachutist jump from a balloon at time t is equals to 0. So this is a point where when he jumped. He reaches the ground at position B. The point A indicates when the parachute was open. So this is a point. On a figure label, on a figure 1.1 label on the graph where the acceleration is 0 as 1. Acceleration is 0 means like constant speed. So it should be a horizontal line because slope should be 0. So anywhere we can mark 1 here. Negative acceleration negative means deceleration, and deceleration means the speed decreases. So which position the speed is decreasing? So you can see this position, the speed is decreasing and decreasing with the acceleration is decreasing. So slope should decrease. So which region the slope is decreasing? So anywhere we can mark on this region. So that's just point 1, 2, and 3. The next is explain. Look, this is a very structured answer for this question, such question in which you have to explain a falling object and reaching a terminal velocity. So explain in terms of the forces, the change in the motion which occur from when the parachutists leave the hot air balloon until point A. So till point A means till terminal velocity. So first what will happen? What should be the structure of the answer? When he jumps, acceleration is due to gravity, which is 9.8 meters per second square. So the moment he jumps, when he jumps, the acceleration is due to gravity, which is equals to 9.8 meter per second square. Then what will happen? The increase in the speed increases the air resistance, which reduce the resultant force. Because air resistance is always opposing the motion, so the resultant force decrease and acceleration. So resultant force decrease, so acceleration will also decrease. And eventually what will happen? Air resistance balanced with weight, no resultant force act on the parachutist. he will continue to move with constant velocity known as terminal velocity. So this is a very structure, and when he reaches a terminal velocity, there is no resultant force acting on him. Okay. So when air resistance balanced with the weight, no resultant force act on him, he will reach a terminal velocity or constant. We just have to explain till point A. So till point A is a terminal velocity. The next student catches a cricket ball at a speed of the speed of the ball immediately before it caught was 18 meters per second, and the mass of the ball is 160 gram. SI unit of the mass is kilogram. So if you see any question other than specific heat capacity, because in our density question as well, if the density is gram per centimeter cube, then mass should be in gram. Or a specific heat capacity question, if the specific heat capacity is given in joules per gram degree centigrade, so you will use that in gram. Okay. Rest all of them you always convert into kilograms. So kinetic energy is half mv square. Why it's of 3 mark? Usually a 3 mark question indicate either two formulas are used or a unit conversion is there. So this is also an indication that, because normally numericals are of 2 marks, 1 mark for formula, 1 mark is for answer. But if you see 3 mark numericals, so either, and if it is a 4 mark, definitely two formulas are used. But if it's a 3 mark, definitely it give an idea that there might be a unit conversion. So from the marks, you can identify that whether I have to convert a unit or not. So if when you see 3 marks, it's give an idea that it involve a unit conversion. If 4 mark, it means it involved two formulas. So kinetic energy is half mv square. So we will put half. The mass is in gram. So we'll convert into kilogram, divide by 1000. So 0.16. And the speed is equals to 18 square. So half mv square will get this kinetic energy in joules. It takes 0.12 seconds to catch the ball and bring to rest. Calculate the force. So if you recall the formulas of the force, what are the formulas of the force we can use? One of the formula of the force, F is equals to ma. Another formula which involves the force is impulse is force multiplied by time. So if force is impulse divided by time. Or another formula is pressure is force acting on unit area. These are, but here we don't have area or pressure, we cannot use. But we can use any of these two, because impulse is a change in momentum. Mass is given to us in the beginning, the mass of the ball, and we have also know its velocity. Because the ball was moving at a speed of 18 meter per second and it was caught. So when it is caught means it will be stopped, bring to rest. So the initial speed is 18 and the final speed is 0. What about the time interval? The time interval, that is 0.12 seconds. So if I use a formula, F is equals to ma, force is equals to mass times the acceleration. So force is mass times the acceleration. The mass is given, but that mass is given in kilogram, which was, oh, sorry, gram. We have to convert it to kilogram. This is mock 3, set 3, paper 4. So it is 0.16. 0.16 is a mass. What about the acceleration? You can work out the acceleration, which is a change in velocity divided by time interval. Later. I will give. Later I will give. Acceleration is a change in velocity divided by time. So the initial velocity is 18 and the final is 0 and the time interval is 0.12. So it will be 0 minus 18 divided by 0.12. So that is the acceleration and this is the mass. So when you multiply, you will get the force which is acting on the ball. As the student catches the ball, she moves her hand backward explain the effect of this action on the hands. So look, when we stop an object, we have you have to relate impulse and the momentum with force. Impulse is force multiplied by time. So when we stop the ball, why can we direct? Why we cannot use 160 gram? Because 160 SI unit of the mass is kilogram. Yes, this is mock 3, mock paper 4, set 3. Question number 2. Yes. So impulse is force multiplied by time. So if we stop any object which was initially moving at 18 meter per second and then we stop. So if we take longer time, as the student catches the ball, she moves her hand backward. So it means she will take longer time to stop the ball. So for a same impulse, if we take longer time, so what will happen? The force experienced by the person or the student will be less. So this is what happened like in a cricket as well. When a keeper is catching a ball, they tend to move their hand backward. Why? So that they will take more time to stop the ball. So if they take more time, so less force they will experience. Even same thing for football as well. Any case, like a ball is moving. So if you try to instantly stop, you will experience a maximum force. But if you gradually stop, it will experience less force. So here the answer is for a same impulse, longer time means less force. So it will exert less force on the gloves or the hands. Whenever we are stopping an object, so if we are stopping an object, if we take like example 2 seconds, object was moving at a speed of 18 meter per second and we stop after 2 seconds. And another case, object is moving at a speed of 18 meter per second and we took 5 seconds to stop. So if we take longer time to stop an object, the force which is needed to stop an object, the decelerating force, that will be less. So we will experience a less force. So if I want to stop anything instantly, I have to apply greater force. Like a ball is thrown towards you and you want to stop instantly, so you have to apply greater force as compared to you catch it and move your hands backward. Same thing happened for the seat belts as well. Same thing happened when a person jumps from a certain height. If he take longer time to stop, he will experience a less force. Figure 3.1 shows a person moving across the ice-covered pond to reach the ball on the ice. Explain why this way of moving across the ice is safer. Use your understanding of a pressure. So, look, he will have a large surface area in contact. What is the relation between a pressure and area? Pressure is force acting on unit area. So if he's having a large area in contact, so the pressure on the ground will be low. So means less likely he will sink in the pond or break the top surface of this or crack the ice. So here, how you score the 3 marks? Like in this position, the person for a same force, because his weight is not changing. Force is constant, or you can say weight is constant. Weight is not changing. In this way, there is a large surface area in contact. If there's a large surface area in contact, it means less pressure on the surface. So he will exert less pressure on the surface or less likely he will sink on this surface of the pond. Okay? Clear? The next is figure 3.2 shows the side view of a pond with a layer of the ice which is floating on freely on the water. The surface area of the pond is 5 meters square. The mass of the ice is 690 kilogram. The density of the water is 1000. The point X is 0.4 meter below. Calculate the pressure at point X due to the ice and water. First, how to get the pressure of the ice? The pressure of the ice, they already give us, yeah, force divided by area. Because for ice, the surface area is given to us, but this is a mass is given. So how to get the force? Input to 9.8. Because the force will be equals to weight of the ice. So this will be 619 to 9.8.
6,762.
6,000?
762.
The mass use mean.
Yes.
6,762 Newton. So that is the force of the ice. We got the weight or the force of the ice, and the area is already given to us. How much is the area? 5. So what is the pressure exerted by the ice? That is force divided by area. So 6,762 divided by area is 5. What's the answer?
1352.4. 1352.4.
1,352.
0.4.
Okay, 1,352 Pascal. That is the pressure exerted by the ice. Then what is the pressure exerted by the water at a depth of a point? So if I need the pressure, so we need the density, gravity, and depth. So density is how much? The density of the ice is 1,000. Sorry, density of water is 1,000, gravity is 9.8, and the depth is 0.45.
4410.
44410 Pascal. So means what is the total pressure? The ice is exerting a pressure. This is the pressure of the ice, and this is the pressure exerted by the water. So what will the total pressure? It will be the sum of the pressure of ice plus 4,410. What is the sum?
5,762.
5,762
Yes.
Pascal. What? Okay. 5,760.4 Pascal will be the answer. Okay. 62. Yeah, 62 because this 2 is there. So 5,762 Pascal will be the pressure exerted by this. So we need the pressure of the ice. We got it. And then we got the pressure of the liquid. And we just add them to know the total pressure. What if there was a question, like let's say there is a question and they asked calculate the total pressure and there was no ice. In that case, what we will do? If they give us actually, when we calculate, there is another pressure. Atmosphere is also there, but they did not give us in this question. So we just calculate the pressure of ice and pressure of water. But actually, there is another pressure. What is that pressure? Atmosphere. So atmosphere is also exerting. So there is a pressure of atmosphere, there's a pressure of the ice, and there's a pressure of water. So actually, the total pressure, yes.
They'll always give us the.
If there is a, like if you have to atmospheric pressure, they will provide. You don't have to memorize the value. So how you will know whether you have to atmospheric pressure or no? So when you read a question, if they provide you the atmospheric pressure and they ask the total pressure, definitely you have to add the atmospheric. If they only said calculate the pressure of the liquid, just multiply density, gravity, and depth. If they ask the total pressure, if they ask us what is the total pressure and they gave us the atmospheric pressure, we'll add all of them. In question 4, the temperature for a fixed mass of a gas at a constant volume decreased. Explain in terms of the particle how the pressure of the gas changes. So the temperature of a fixed mass of a gas, which is at a constant volume, decrease. If you decrease the temperature, what will happen to speed or a kinetic energy? The speed of kinetic energy will decrease. So pressure, speed, and the kinetic energy decreases. So as the speed or the kinetic energy decrease, there will be less collisions between the molecules. As less collisions are there, so they will exert less force on unit area or reduce the pressure. So relate them, like speed or kinetic energy decreases.
Temperature will decrease.
Yeah. As the temperature decreases,
So there are less collisions.
less collisions exert less force on unit area. Or there will be a small or lower pressure. Pressure depends on two things. It depends on how hard the molecule hit and how many molecules are hitting. Okay. Both factors it depends on.
Sir,
Yes.
for the ice questions,
Hmm.
sir, when they walk on the ice,
Hmm.
people usually wear boots which have small surface areas.
No.
The
Two things are
like
different.
spikes one.
Not if we want to if we want not spikes are not used for the ice like if we want a grip, we want a grip we want to stand firmly at one place, then spikes are useful. But if we want to walk, because like example climbers are using spikes. Why climbers are using spikes? Because they want a firm grip. They want to exert more pressure on a unit area, so they will remain at that place. But for example, a skier, he's not using spikes. He uses a large surface area, so less pressure he can slip over. So if you want to slip, exert less pressure, then large surface area. If you want a firm grip, small surface, like the football players, the cricket players, they are using spikes because they want a grip to the ground. Yeah, the spikes gripper, it's the same thing. Yeah, studs, but it's the same concept because small surface area, large pressure will be there. So state the value of absolute zero. What is the value of absolute zero? 0 Kelvin. 0 Kelvin is equivalent to what? It is minus 273 degrees centigrade.
Then, but why is this a absolute zero?
Because it is zero equal to 0 Kelvin.
Why?
This
Because
at this
when you're
temperature,
at the lowest-
theoretically, what happened when we cool down the gases? Theoretically, at 0 Kelvin, the gas particle stop vibrating. They don't vibrate. That's why we call that's absolute temperature. If you write minus 273.15, that's correct as well. Explain what is meant by term absolute zero and refer to the particle in your answer. So absolute zero is actually refers to a lowest possible temperature or a temperature at which the particles have minimum kinetic energy. So it's a lowest possible temperature and the temperature at which the particles have the minimum kinetic energy, that is known as the absolute temperature. Temperature, which one? This one? Lowest possible temperature at which the particles have minimum kinetic energy. The least kinetic energy, minimum kinetic energy, even zero kinetic energy is fine.
Sir,
So if you at even we get the one.
No. Write the full.
maybe
Write the
let's
full.
say that this way of moving across the ice is safer than walking. So don't we need a
No, he don't want to
bigger
sink. He don't want to sink because he's walking on the pond.
Yes.
So if he's walking on the pond, he want to exert less pressure. If he was like he's not climbing the mountain, he's walking on the pond, so he want to exert less pressure. That's why he he lie down on the surface, so the force is spread over the unit area, exert less pressure. Particles have no energy. You can mention, but try to learn the standard term. Better the important thing, because the temperature and kinetic energy are related. So you have to say a kinetic energy. So absolute zero is the temperature at which particles do not move. Yeah, you can say that, but it is very important to use the term kinetic energy. A cylinder containing 350 cm cube of a gas at a pressure this. So we have V1, we have P1. For these questions, unit conversion is not important because you are taking a ratio, so unit is not at all important. The gas is transferred to a cylinder of a pressure 1.6 P2. What is the volume of the cylinder 2? So we just have to use a formula P1 V1 equals P2 V2. So P1 V1 equals P2 V2. So first pressure is 9 exponent 4. The second, the first pressure is 350. The second pressure is 1.6 exponent 5, and the second volume is unknown. Multiply, this is multiplied, other side divide. What's the answer?
196.87 centimeter cube.
196 centimeter cube.
Yes. 0.8
No, it
or
was
197.
197, okay. 197 cm cube. Yeah, because 200 rounded off answer 200 thousand.
इसमें कितना है? इसमें कितना है? लेकिन 59 out of 60 है। 59 out of 80 है। मैंने सब कुछ इसमें मिला था।
Figure 5, the next question, figure 5.1 shows an electric heater used to heat the room. The dimension of the rooms are given. So we have the dimensions of the room, which will give us a volume, and we have the density. Calculate the mass of air. So density is mass present in a unit volume. So mass is density times the volume. So density is 1.2 and the volume is 4.5 times 6.1 times 2.4. What's the answer?
79. They gave me it. Just have it. That tomorrow है ना, करते रहेगा।
हाँ,
79?
कुछ भी नहीं आया।
So 79 kg.
एक पहले तो हाइड्रोजन का अलग से निकालना था। हाइड्रोजन का अलग से निकालना।
Next, the power of the heater is 1100 watts. So we have the power. The specific heat capacity is 1000 joules per kilogram degree centigrade. Calculate the calculate the time to increase the temperature from 16 to 20. So we have the formula that E is equals to Cm delta T. And energy is power into time. So in place of energy, I can write power into time is equals to specific heat into mass into temperature change. How much is the power? It is a 1100 watt heater. The time is unknown. The specific heat capacity of the air is 1000. The mass of air in the room, we already calculated in the previous part, which was 79. And the temperature change, it started from 16 and ending at 20. So the temperature change will be 20 minus 16. So if you need T, 1100 will be divided. How much time it take?
27.275. 27.
Rounded off, tell me.
287.
So 287 seconds according to the calculations. So energy is specific heat into mass into temperature change. So you just divide.
It's radiation.
Radiation what? Harmful?
Can radiation transfer thermal energy?
Yes, thermal energy is by radiation. IR infrared.
I have wrote radiation and B, then they use in
Because here, why it is not possible? Because the particles are there when there is no.
Glass में जा सकते हैं।
No, if you suggest one reason why the time calculated is a minimum. So because energy lost to the surrounding particle may lost. So because energy lost to the surrounding. No, but what will happen? We just take a air which is in the room. But what might happen? Air might lost to the surrounding. Like that. Yeah. In the room we have air. That air might, what we did, we heat a room, increases the temperature from 16 to 20. But what might happen? The air will escape from the room. So that air moved out from the room. So it means it will also.
It's like impossible thing. How?
What impossible? Now it's happening. Air is escaping.
It's coming inside. It's
No, no, it's not coming in. It's a ventilation is there. One region it enter, one region it goes out. Convection, yeah, air move.
सर रेडिएटर की पावर से वो कोई और भी तो फॉर्म में जा सकती है सर। कोई और फॉर्म में वो जो रेडिएटर है जो वो हीट कर रहा है उसकी भी तो पावर कोई और वे से लाइक वेस्ट हो सकती है सर।
Yeah, it
सर्किट से मूव कर रहे हैं तो उसमें वेस्ट हो सकती है
But the question was, yes, you are right. But if you read the question, they say explain why we calculated that air should take this much time to heat up to 20. They are saying why this is a minimum time, why it may take longer than what we calculated. So the question was related to air rather than for a heater. In the second figure, 5.2 shows a cross-section area of a double glazed window in the room. As you can see, a narrow air gap is there.
रेडिएशन हर टाइप से वो जा सकती है
For this third part, it's energy loss to the surrounding or particles of air move out from the room. You can mention any one of them for the third part. This one state the main method of thermal energy transfer from root to outside, which are reduced by this type of a window. Yeah, conduction, but not radiation. Radiation can pass through the glass. If you read the main method of thermal energy transfer from the room to the outside, which are reduced by this type of windows. Reduced means which will not happen. Radiation can passes through gap. Radiation can pass through the gap.
which are reduced by this
So that's why radiation is not acceptable. You can say conduction, you can say convection, but not radiation. How a window will stop the radiation? Like radiation can pass through the glass. Radiation, no. Which type of heat radiation cannot pass? Longer wavelength, like it reduces. Yeah, blue, like example, radio wave, amount of radiation which passes through a wall, intensity decreases. But yes, it can pass through. No, the answer for this one is just the method which is reduced. So you can say conduction or convection.
Since they said main method.
Yeah, both.
You said either.
Conduction and convection.
either one of them
State the main method of thermal energy transfer from the room to the outside, which are reduced by. So conduction and convection are reduced by this.
Yes, I know, but you said you can write either conduction or.
They do accept here.
This is methods, not method.
They do accept.
वही यार क्या है यार बहुत ही एक्सेप्ट करते हैं तो
For anyone, if one is wrong, they will give you the mark.
No. If a mark is there, like example, if let's say blanks is having three blanks, three options are there. If all three are correct, you will score 2 marks. If one is mistake, 1 mark.
For this question, like I wrote conduction and radiation.
Yeah, they will give them.
Conduction, convection, and radiation.
That you will lose the marks. Radiation should not be there.
बोला ही नहीं चाहिए
Like on the mark.
Shiny surfaces can stop the radiation.
वो सही इसको कैसे भूल गए सर
That is the mark. Yeah. There was a conduction.
You give us too much work, look.
Yeah, I know.
Just for you, sir.
Thank you.
what yeah
Just kidding.
State type of the waves that P and the S can model. So what are P waves?
Longitudinal
बहुत काम है.
Yeah, both is.
transfer.
भैया preparation तुम अपनी कैसे करते हो
बस.
Then what do you think
तुम अपनी preparation कैसे करते हो
P is a primary wave, S is a secondary wave, which is produced during an earthquake. P stands for primary, S stands for secondary.
तुम करिए
Seismic waves are the waves which are produced by the earthquake.
S wave is transverse.
S waves, yeah, S waves are transverse, P waves are longitudinal. The velocity,
You have to remember.
yeah, memorize this example.
मैंने तो इतना खतरनाक तुक्का मारा
You cannot say P waves are radio waves because you have to state the type here. Types of the wave. There are 2 types of the waves, longitudinal and transverse. You have to state that.
So S is transfer
P waves are longitudinal, S waves are transverse.
बताओ मैंने ये कैसे याद किया था क्योंकि मैंने बस यही था कि मैं ट्रांसफर्स के साथ S
The velocity of the P in the earth crest is 7.2 km per second and the frequency is 4.5. Calculate the wavelength.
S
So speed is frequency times the wavelength. If you need the wavelength, it is speed divided by frequency. The speed is 7.2. You can convert into meters per second, but what about the frequency? It's 4.5. So if you write the answer 7.2 divided by 4.5, you will get the answer in kilometer. But if you convert the speed into meters per second, so 7,200 divided by 4.5, then the answer will be in meters. So it depends on, if you use a unit kilometer per second, the answer will be in kilometer for the wavelength. Acceptable this, because they did not specify. So, and we are not, like, let's say a question was there, find the speed, and the wavelength was in kilometer and the frequency is in hertz. So then answer will be kilometers per second. I don't remember exactly. Yeah. No, I just collected for the set 4. I collected the question, set 1 and set 4. Yes, if you write answer in kilometer, that's fine. Figure 7.1 shows a container of oil. A ray of a light shines on the surface with a refractive index of 1.47 on a figure. Draw a normal at a point where the ray enters. So normal is always perpendicular to the surface. So this will be the normal.
So if we start from above the line,
Which above the line?
like we start at the borderline.
Here?
Yes.
Yeah, fine. Then the angle at x is 56. What is the angle of refraction? How to work out? First, you need the angle of incidence. The angle of the incidence is always between the normal. This angle is 56 degrees. So how much is this remaining? 90 minus 56. So that is equals to 34. So 34 is the angle of the incidence. So use a refractive index, which is sine angle I over sine angle R. Yes?
If we write the formula only, will we get 1 mark?
Yes.
For refractive index?
Yes. So refractive index is sine angle I over sine angle R. So refractive index is 1.47. Sine angle of the incidence is 34. And angle of the refraction is unknown. Cross multiply. So sine angle R will be equals to sine 34 divided by 1.47. Sine 34 divided by 1.47, and you need a R. You move sine inverse other side. That will give us the value for R. What's the answer? What's the answer?
I'm doing something else right now.
Sine 34 divided by 1.47. 1.47. So this is 0.38. And then take a sine inverse of this number. Yeah, shift sine inverse. Press shift sine 0.38. 22? So 22. So 22 degrees is the angle of refraction.
22. No, 23.
I got a math error.
Yeah, exactly.
So after rounding it off, it will be 23.
Okay.
22.3.
It's 20,
22.3. Okay. State the approximate speed of a light in air. So 3 into 10. Learn the speed of a light in air as well as speed of a sound in solid, liquid, and a gas.
For the formula Sinai over Sinai.
The answer for yes.
For the formula, the numerator will be greater than the denominator.
Always. But here you don't know, so you have to remember a formula. And obviously, the angle of a refraction is smaller. It should be smaller because the light is moving from air. It is bending into. So definitely the angle will be smaller. So